Brian Cox will be fully utilising the science budget and travelling around the world to explain the kinetics model.
Okay, so Brian, what is the kinetic model? The kinetic model is the model we use to think about the classical representation of all matter. And in order to think about it, we have to make some assumptions about the nature of matter. First, that matter is made up of billions and billions and billions of tiny particles. And secondly, we have to assume that these particles move about. So we have solids where the particles are arranged neatly in a lattice, which means they can't move, so they just vibrate about a point. Secondly, we have liquids where the particles are still close together, but they can only vibrate slightly because they're disordered. And that's just wonderful. And finally, gases, which are not like the other two. The particles have much more energy, so they fly about and bash into one another in the walls of the container, which is why they spread out. Okay, right. Well, thank you very much. So solids, liquids and gases, showing the particulate nature of each one. The solids are regularly ordered with very small gaps between them. Liquids are also have very small gaps, but they're not regularly ordered, they're totally chaotic. And gases are not at all close together, they're miles apart. And they fly around very fast and bash into each other and into the walls of the container. Okay, so I've come here to the Nullarbor gold mine in the Kalgoorlie in southern Australia, and I've come to see this rock, and it's truly astonishing because it is so solid. So this is crystalline solid, and that means that the particles within it are regularly arranged. So these are the particles within a solid, and you can see they're all regularly arranged, and they can't move about much, so they vibrate within themselves in a lattice. So I've come to the Amazon rainforest, one of the wettest places on the planet, and I've come here because it contains copious amounts of the most abundant liquid on the planet, water. This graph represents the temperature change against time for the heating of a material from solid to liquid to gas.
We We've come out here to talk to Professor Brian Cox about the kinetics model.
So I've come here to the Himalayas to talk about gas. And the best example of gas on our planet is the atmosphere. The higher we go, the less molecules of gas there are in the atmosphere. So I have to take air with me. And I'm using popcorn to represent the particles of the gas. They're really good because it acts just like a gas, and you can see that the particles of the popcorn fly around and collide with one another in the container at high velocity, behaving just like the particles of a gas. And this is why gases exert pressure on the inside of containers and why they expand to fill the space, as you can see the popcorn is doing.